Welcome everyone, and thank you for joining today's webinar. My name is Ian Schooler. I am the MD of TMSG. So why are we here today? Underfloor heating is growing in popularity, but many still believe it's too complex, expensive, or not suitable for retrofit applications in upper floors. Hopefully, we can put some of those myths to bed today. Whether you're a homeowner, installer, builder, or part of the construction industry, this session is packed with valuable insights for you. The agenda formats: how underfloor heating works, why our systems are different, underfloor heating types, and questions and answers. But before we get into that, I just want to do a little bit of housekeeping. Zoom functions overview question and Q&A tab located at the bottom of your screen. Drop your questions here anytime. We'll answer as many as we can at the end. Chat function. If you have any technical issues, use the chat and our team will assist you. Recording. Can't stay for the full session, no problem. We'll send the recording to all registered attendees. So we'll get started, but before I just introduce the panelists and the people presenting. Dan Clist, Technical Training Officer at Omni, will walk you through how our underfloor heating solutions are changing the game for both renovations and new builds. Joining him and supporting will be Michael Clark, Business Director, TMSG, Ryan Surt, Business Development Executive, TMSG. So at this point, I'll hand over to you, Dan.
Lovely. Thank you, Ian. So, underfloor heating, how does it work? Well, it's actually a really simple concept. It's plastic pipes embedded within the floor. Through that, we're actually then passing water that is warmed by either a radiator, not a radiator, sorry, by a boiler, by a heat pump. Then that water goes through the floor, takes the floor temperature up to a certain point, and then once we get to the kind of design level, we start to emit some heat into the room, and the underfloor heating then heats the room to the kind of desired comfort temperatures in effect. And there are some distinct differences between underfloor heating and the kind of equivalent radiator. So with a radiator system, we are kind of limited by our heat emitter area. So bigger radiators tend to be slightly unsightly. So by keeping the radiators small, to get the required heat output from those radiators, we've got to run them hotter. So if I've got something like a heat pump, I've got to get the heat pump to work harder to produce the temperatures I need to get the heat out of the slightly smaller radiator. Whereas with underfloor, my entire floor area is in fact my radiator. So much bigger surface areas means I can get away with much lower flow temperatures, which then comes back to the whole kind of efficiency thing, if you like. The fact that the underfloor heating uses the entire floor as my heat emitter, it's a much more even spread of heat across the floor, across the room. So I don't get hot spots, I don't get cold spots, because the entire room tends to be heated at the same kind of rate from the floor upwards, which is a much more natural way for the human body to be heated. So it's like being stood in the sun shines on the ground, and you're heated from the ground upwards in effect. The other thing with radiators is it does start to restrict your wall space. If you've got a modern house that's kind of open plan, you start to lose space to hang radiators. You take your walls out for all intents and purposes, which then starts to limit where you can put those radiators. And where you put those radiators then starts to impact the overall design of the property, where you can hang big TVs or kitchen units, whatever it might be. It starts to become a lot more impactive. The other thing to bear in mind is where we put radiators. So we generally put radiators under windows. And the reason we do that is for a number of different reasons, but one of them is to make use of the dead space. In effect, the space under a window tends not to be used for anything particularly. So by putting the radiator there, we're making use of space that would otherwise be redundant. One of the good things with that is we've got a bigger temperature differential, if you like, which means that the the colder air coming through the window drives the convection away from the radiator. So that works quite well for a radiator. But what that then means is when you close curtains at night, you're actually then encompassing or enclosing your radiator, the TRV, which is for all intents and purposes the control of that radiator within the curtains. So as the room starts to cool down, because we've covered our radiator basically, the radiator warms the area around the TRV because it's encased in a curtain, which then shuts the heating off in that kind of area. So having radiators under windows isn't particularly good with low temperature systems because it starts to influence the way that they perform. So we then start to need to put those radiators somewhere else, which we're then back to this kind of more visually impactive issue with radiators. Like I said, with underfloor heating, my entire floor area is used. It's a much more even spread of heat. It's a much more comfortable spread of heat. It frees up the entire wall area for your interior design, however you want that interior design to operate or to work. You're not having to compromise because you've got big steel panels stuck to the wall, basically. From a healthy perspective, underfloor heating is a radiant form of heat, so it tends not to use convection currents like radiators do, which then means that we're not pushing dust and stuff around the rooms. So if you've got people with respiratory issues, asthma, whatever it might be, you'll find that living in a house that's heated by underfloor heating is actually a much more comfortable environment, certainly within the first couple of weeks of the heating season starting, because we're not circulating stuff around the room for them to kind of breathe in effect. What else? In terms of solutions for underfloor, there is so many different kind of options in terms of how we can install it. But actually, just going back to some more of the advantages, it is a much more comfortable environment to be within. The way that we run underfloor heating, or the way we recommend underfloor heating is run, is we tend to want to leave it on for longer periods of time, meaning that rooms are kept at a much more constant temperature. We don't have quite large swings in temperature throughout the course of the day as you would expect with a radiator system. And the beauty of doing that is we're starting to compromise, or we're trying to get away from the compromise with underfloor heating to a certain extent, which is the fact we've got to heat the floor up before we start heating the room up. And if we keep the rooms at temperature, we're mitigating that slight lag time in effect that we get with underfloor heating. And then if you look at the efficiency side of it, actually running a heating system more consistently without having it switching on and off through the course of the day is actually a much more efficient way of heating a house, as opposed to like you might do with a traditional radiator system where it's on for an hour in the morning and maybe an hour or two in the evening. Keeping everything at a constant temperature, which is what we really want to do with underfloor heating, actually returns quite good results in terms of a reduction in energy consumption. From a safety point of view, now we're eliminating radiators almost exclusively. So with underfloor heating, it's encapsulated within the floor itself. So there's no sharp edges, there's no steel panel stuck on the wall that people can bang into to knock themselves against. And like we said, it frees up that wall space, so you're completely free to do what you want within the room in terms of your interior design. And then moving forwards, if you're kind of painting and decorating, you're not having to worry about taking radiators off the wall to paint behind them or to paint wallpaper behind them, then put them back up again because they're not there with underfloor heating. So that becomes a completely redundant worry almost. And then from the low temperature side of things, certainly with a drive towards energy efficiency, certainly with a drive towards heat pump systems specifically, the lower the flow temperature we can achieve with our heating system, the more efficiency we're going to get out of the appliance. And that applies to anything basically. So whether it's a boiler or whether it's a heat pump, but certainly with a heat pump, it's a much more important thing to try and drive that flow temperature down as far as we possibly can. Ultimately, it's better from the environment, and we're consuming less energy, you're actually paying for less energy as well. So there's other tangible um, benefits to that as well. So if we go on to the next slide, so yeah, why are systems different now? From what I understand, at the moment with you guys in Ireland, there is a screeded floor systems are quite a common thing. It's a sort of a well understood mechanism for installing underfloor heating. But where our products are different is we're actually equipped to be able to heat floors above the ground floor level. So we've got options over and above a standard screeded option, which then means in a retrofit kind of scenario, there are a significant amount more options available for retrofit applications, even for new build applications as well, which then means that we're opening up not just the ground floor for underfloor heating, but the first floor, second floor, whatever it might be. So there are options that work incredibly well in other situations other than just a screeded installation. And some of the issues with screed is it takes time to dry, it's expensive. There's from an environmental perspective, there is a lot of carbon associated with screed and concrete type floors. So eliminating screeds or reducing the amount of screeds that's used actually has a good impact in terms of its environmental status, environmental impact. And then with upper floors, it means you can do away with radiators in bedrooms, bathrooms, areas that you might have upstairs. Even for other ground floor options, if you like. So if you've got a system where you've got a suspended ground floor, traditionally you may have had to go down the route of radiators or potentially backfill the underfloor void with insulation and then screed it anyway. But in those systems where you've got a suspended ground floor and that isn't an option, we have floor construction solutions that then mean we can install into a suspended floor, whether it's a ground floor, first floor, second floor, whatever it might be. One of the good things about going away from screed is that we start to take what's called thermal mass out of the system. So with screed, you've got quite a lot of stuff that we need to heat up before we start emitting heat into the room. So if we get rid of that, we start to reduce the thermal mass. We start to reduce this kind of thermal lag time that can be associated with some of the underfloor heating solutions. So with the kind of lighter weight, less screed orientated type solutions, we can actually have a system that will respond significantly quicker than a screeded floor, almost to the point where it will respond as quickly as the equivalent radiator system. So if you did want a system where you could turn it on and off, run it at lower temperatures during the day and back up to temperature of the evening, or whatever it might be, that becomes a much more viable proposition with some of these other non-screed based floor constructions. From a retrofit perspective, obviously with the screed, you've got the actual depth of the screed, which could be anything from 50 mil up to maybe 65, 70 millimeters on top of polyiso type insulation. There's quite a lot of height actually associated with that. So with the kind of the overlay type systems or the interjoist type systems, the beauty of them is they're very, very low profile. So you can achieve all the benefits of a wet underfloor heating system and the efficiency benefits that you get from that in a system where you may only have something like 18, maybe even 20 mil of height to play with. We've got a solution that will fit within those kind of constraints and still operate in an extremely efficient and a much more comfortable environment for you to actually live in, because you're using the underfloor heating in these particular applications. The products that we have are they're well tried and tested. A lot of this stuff has been around for years. We're talking sort of 10 or 15 years within the UK market. So they're well tried and tested. So we know that they work. So we've done all the kind of the R&D and the fine tuning and everything else to the point where we're confident in the way that they perform, how you install it, and kind of the ongoing servicing and maintenance and things like that as well. So our products use something called Alhex. So where you've got an encapsulated pipe system, so something like Torfloor or the some of the overlay systems where it's in effect the floor is made up of two sections. The upper board has an aluminium foil laminated to the back of it, which has it's almost like a honeycomb shape stamped into the foil. So as you put the cover board over the top of the pipe, it starts to form over the top of the pipe itself, which gives us a much better thermal contact into the upper board of the floor, which then allows the heat to transfer into the surface of the floor and then re-emit out into the room. So having technology like that gives us a system that performs better than a lot of the other potential options that there might be in this particular kind of application for underfloor heating. So we've got options where we'll go, obviously, the screeded floors, between joists, overlay systems. So if you've got an existing floor that you for whatever reason you can't pull up or you're reluctant to remove, we've got systems that will lay straight over the top of that. And certainly on the suspended timber type floors, we've got solutions where we replace the structural element of the floor, as in the floor deck, with a 22mm chipboard, which is routed to accept a 12mm pipe. Pipe goes into that, and then a 6mm cover board goes over the top of that. So you've got all the benefits to the underfloor heating. You're only having to pay for the underfloor heating, not then having to pay for the additional structural floor deck. And everything's encapsulated with a sort of a 28mm height build-up. So the actual impact in terms of the floor level is only another 6mm to kind of to find and to play with. And ultimately, a lot of the stuff that's not screed based is actually a lot quicker to install. Certainly doesn't have the drying times associated with screed. So once everything's pressure tested, you can get on and lay the floor over the top of that, and you can complete the system within a few days as opposed to a few months with a screed system. If you're looking at laying it off to dry for whatever it might be, sort of 3 months or so, whatever it might be to dry screed properly. It's like I said, it's a really fast installation. So with this, we're looking at Torfloor 2. Now, Torfloor 2 is a fairly unique product. We were the first to develop a structural deck. And as we said, this one is a 22mm P5 moisture resistant board. It's a standard flooring product, so your chippy will understand how to use this particular product. That's then routed to a depth of about 8mm or so to accept the pipe. So the pipe's laid into the structural deck. Once we've connected the pipe to the manifold, we then pressure test. And once we're happy with the pressure test, it's a 6-bar test for 1 hour. We then lay the cover board over the top. And it's the combination of the chipboard deck and the cover board that gives us our structural integrity. So with that, the kind of the thing to bear in mind is you're actually buying the structural floor and underfloor heating in one go. So you've got some counterfactual costs there you can look at offsetting. And it's a really easy, clean install. If you're doing it yourself, it's the sort of thing to keep into account. Is it going to be a difficult install? And certainly with a floor construction of this nature, it's actually a very straightforward installation process. And our manuals are very, very detailed and take you through that kind of step-by-step process of the install. Types of underfloor heating. So I've mentioned these already. There are a huge range of different options that you can have. But if you kind of strip out all of the individual kind of connotations with those ranges, what they actually boil down to is actually 4 base configurations. So you've got your suspended timber floor constructions, which can be used on a ground floor or first floor, second floor, whatever it might be, wherever you've got some form of timber structure. That can be used in both new build and renovations. We've got a low board, which is an overlay system, which lays directly over an existing floor. Again, that can be a ground floor, it could be a first floor or a second floor. We've got the floating floor systems, which tend to be a little bit more lightweight. They're based on XPS or EPS. So they're a more polystyrene type product, but it means they're lighter weight. So if you've got systems where the floor can't withstand too much additional weight to them, the XPS or the EPS type systems are actually a really good option. And the thing with those as well is that, again, there's very little thermal mass. They do respond very, very quickly. And then kind of the very much tried and tested screed systems, and that can be sort of different variations more around the way you hold the pipe into the insulation before the screed's laid, basically. So we tend to use staples. It just gives a lot more flexibility in terms of kind of laying the pipe out at the end of the day. Okay, and then some frequently asked questions. So one of the things we do need to take into account is the floor covering that you're going to be using. Um, with underfloor heating, we're actually quite heavily regulated by a European standard, which is EN 1264. One of those stipulations is around the maximum temperature of the floor that we can actually take the floor surface to. Um, the reason why it's important to consider our floor covering with the design of the underfloor heating is the floor covering can actually limit how warm we can take the surface temperature. Um, things like engineered woods, solid woods, some of the laminate systems, the kind of the more expensive LVT type systems, they'll actually have a limitation imposed by the manufacturers of about 27 degrees. Now, in a new build, well insulated property, 27 degrees isn't really going to make too much of cause too much of an issue. But certainly where we've got older properties where insulation may not be quite to the same sort of level as a new build, 27 degrees may start to impact on the way the underfloor actually performs. So knowing these things early on gives us the ability to start looking at ways we can mitigate it ever becoming a problem. And then the flip side to that is from the manufacturer's perspective of the engineered wood or the laminates, whatever it might be, they'll want to see some form of control over the surface temperature. So we do that with it's just a thermostat that sits in the floor, basically. So if that sensor reads a temperature of over 27 degrees, it just stops the heating working in that particular room until the surface temperature drops down to a safe level for the floor covering. I suppose one of the reasons for that being quite an important thing is some of these floor constructions are extreme, or floor coverings are actually extremely expensive. So by having some way of protecting that investment, it's always a good thing. Carpets is something we do get asked about quite a lot. There isn't any real reason as to why you can't use carpets with underfloor heating. They actually work relatively well. The thing to bear in mind is the thicker the carpet, the more thermally resistive the carpet is going to be. So ideally, we want to keep the carpet and the underlay to around a combined TOG rating of somewhere between sort of 1.5 and 2. Any more than that, it tends to be a little bit too resistive, and it can actually then start to impact the way that the heat's transferred from the floor. Tiles, ceramics are brilliant, absolutely amazing to use with underfloor heating. They're very dense. They tend to be very thermally stable as well, so they don't expand and contract too much. And as long as they're installed with a decoupling membrane, they're probably some of the best thermally performing floor coverings that you can actually use with underfloor heating. Installation time, it depends on the nature of the floor construction. Some take longer than others, but the thing to bear in mind is the more experienced the person doing the installation, generally the quicker it's going to go. That being said, most of the floor constructions, it's not beyond the realms of reality for a keen DIYer almost to install a lot of it. Yes, it takes longer to install than the equivalent radiator system, but the benefits of going down the route of an underfloor heating system as opposed to a radiator system certainly do counteract that fact in effect. With renewable energy sources, underfloor heating, by its very nature, is a low temperature system. And in a well insulated house with a well designed and well installed underfloor heating system, there's no reason why you can't run underfloor heating with a heat pump. extremely successfully. We can design systems that will run down to maybe 35 degrees if it's a really well insulated property, and then you're going to really start to see the high COPs that you could expect with a lot of the air source and ground source heat pumps. Now, energy efficiency with versus radiators, it's a um, it's a much talked about conversation. I can make a system work equally efficiently with underfloor heating or radiators. The issue being the radiators are going to be considerably larger. There'll be more wall space taken up by them, and they're going to be more expensive, more visually intrusive, and things like that. So there is more just the kind of the efficiency behind behind underfloor heating and radiators. There's more reason to go for underfloor for excuse me, for underfloor heating as opposed to a radiator system, other than just the efficiency. To get radiator systems to run as efficiently as the equivalent underfloor system, they do have to be considerably bigger, which makes them more visually intrusive. And that tends to be the reason to go down the route of underfloor heating as opposed to going down the route of a radiator system. Now, with zoning and temperature control, we zone each individual room, which means that you've got thermostatic control over each individual room. So you can keep your bedrooms at maybe 18 degrees if you wanted to, and the rest of the house at 21. So you've got that individual flexibility over each individual room. And again, as long as we know these things ahead of time, we can put mitigation in place through the design to give you some flexibility in terms of temperature and stuff like that. Suitability for older homes. The floor heating works extremely well in renovations. It's something that's been used for a very, very long time in a renovation application, and with just some fairly rudimentary kind of forethought in terms of levels of insulation, there is no reason why you can't put underfloor heating into an older building or into a renovation. Certainly, some of the overlay systems which have a very low height build up, the whole reason for their design is to be used in a renovation in retrofit aspect. And in terms of maintenance and system lifespan, maintenance is a relatively inert system. The key thing with it really is just to maintain internal water quality. The whole point with underfloor heating is it's a low temperature, so we're running everything at quite low flow temperatures out of the heat pump, for example, which does mean the inclusion of something like a biocide within the system water is actually a good idea, because it just stops any bacterial growth within the underfloor heating, which stops sludge and stuff building up anyway. Other than that, you just maintain the system in the same way as you would any other heating system. So inhibitors according to whatever the boiler or heat pump manufacturer recommends, and then a biocide on the top. In terms of lifespans, yeah, the pipe work in the floor is a 5-layer cross-linked PERT, so it's a cross-linked pipe, incredibly robust. It's got a 50-year warranty with it. There is no reason for it to degrade once it's in the floor. So 50 years at the absolute minimum, I'd say, is a lifespan. Component parts, yeah, there are individual component parts. There are pumps, circulators, thermostats. They all will have a finite lifespan, but we've got systems here that have been installed 25, 30 years ago, and they're still working in exactly the same way as they did then as they do now. So in terms of longevity, because a lot of the pipe work is plastic, there isn't a lot to degrade, there isn't a lot to go wrong. So we haven't got radiators that are rusting and things like that. So in that respect, longevity is very, very good.
I think what we'll do, we'll open it up to a question and answer session.
We have already a question, and it says, does underfloor heating only use heat pumps as a source of heat?
Not at all. We can use heat pumps, gas boilers, oil boilers, biomass. It doesn't really matter what makes the water hot. As long as you've got warm water going through it, it's going to work.
I think just to follow that one up, Dan, I think within the restoration and within the retrofit within Ireland here, there are a lot of existing gas boilers and oil
Mhm.
boilers that are within these older houses. And I think a lot of the people that we've spoken to, the main question is that can these Omni systems be tied into these existing heat sources? And you might just confirm, but what we have been kind of saying is that as you touched on, it doesn't matter where the hot water comes from. So the fact that if in a retrofit, to touch back on a couple of the issues that you had spoke about in terms of radiators taking up space, if you change to some of the Omni products, you can remove those radiators and then you can place centrally your manifold that will tie into one of those radiator systems that will regulate your underfloor heating and run it from there. So if there's in terms of upgrading to underfloor heating, there's not necessarily a great need to adopt or to change your existing heat source.
Absolutely not. No. Just even from an environmental perspective, you've got something that works perfectly well, whether it's oil, a gas boiler, or an oil boiler. It doesn't make any financial sense. It doesn't make any environmental sense to take that out and replace it with something else. So, like I said, we can integrate seamlessly with pretty much whatever you've got there already.
Just a question from my own side, Dan. Now that you're there, it amazed me when I went out that the amount of people that came that were retrofitting their homes. I actually thought that a lot of the shows that we attended on BTC would be new builds, but I'd say probably close to 50% were people that came to retrofit, and they genuinely didn't know there was a system out there that accommodated retrofit. Is that has that been your experience also in the UK?
Certainly when we first got into the retrofit solutions, if you like, underfloor heat, the screed underfloor has always been a thing for a very, very long time. And that the first, I suppose, the first 10 years or so of the company being in existence, a lot of it was around new builds. But there was a definite push from a retrofit perspective to develop something that worked in those kind of scenarios. And the thing with retrofit is we want it to be as we want to minimize the impact on the homeowner, but still give them the ability to put in underfloor heating. So taking floors out is a huge, huge undertaking. So having something that goes over the top of an existing floor, you compromises the depth of that system you're putting down.
Yeah.
But the benefits are you've got a wet underfloor heating system that you can use your existing system boiler on, your existing gas boiler on, whatever it might be. But then you've got all of the benefits of having a wet underfloor heating installed in those particular applications. So it's a market that's grown a lot here over the last sort of 10 years or so, massively so.
Sure. I'm not sure if there's anyone else out there that has a question.
Yeah, we have some questions here. Another one came in, say, can we use our own contractor for installation? And if so, would there be an installation document, video, or session they could attend just in case they have not worked with the system before?
Yeah, no reason why any tradesperson really can install the underfloor heating. The documentation that's provided is pretty in depth. A lot of resource on the likes of YouTube, which goes through the step-by-step processes for the installation, so that the information is always there. And they can always pick the phone up if they get stuck as well.
But the plumbing part, Dan, is obviously comes from a certified plumber. Is that right?
Um, I'm not 100% sure how the regulations stand in Ireland, but certainly here, usually the final connections between the manifold and the heating system are made by a plumbing and heating engineer,
Yeah.
purely because of the complexities of having to cut into the pipework that's already there and the potential to get into some fairly sticky situations.
Yeah.
That tends to be more to do with a more of a reluctance with the install of the self builder to get involved with cutting pipe work and things like that. But quite often what you'll find is the actual install of the underfloor right up to the manifolds will be done by homeowner or builder, whoever.
Yeah.
But the final hydraulic connection between the manifold and the actual primaries for the heating appliance, it doesn't necessarily have to be someone that's a plumber, but it tends to be better if it is because of the potential implications of it not going quite right.
Yeah. I think Mick, I've heard you say before the sign off is on the final part. Would that be right?
Yeah, so just to kind of to go back to the question, and in basically speaking, we as a company we're based in Dublin, but we have a network nationwide. We sell direct to the public. So in terms of say an XPS system or something like that, we have full stocks of that on the ground here, all your manifold, all your pipe, all your fittings, connectors, everything. In terms of your low board two or your tour floor two, what we call um, project designs, they have to be designed by the Omni team. So generally, what we have is 2 weeks from time of order, we can provide a quote based on drawings or plans. So we can provide a quote for your builder, your customer, for yourself, and we can get that to you. But in terms of ordering and in terms of who would fit that, as Dan said, like we've had these done by homeowners. They are a very simple system to fit. They can be fitted by a builder, by a chippy, by a carpenter. But in terms of connecting up, so what you will have in terms of taking your heat source or taking the heat that will heat the underfloor heating, it is tapped in from say your existing copper if it's an older house, and probably the safest place. But if you have a builder, they will have a plumber that will come in to do that, and it will be connected up. You charge your system, and you can set that. As Dan said, heat engineers who are dealing with underfloor heating constantly day to day, they would do this with their eyes closed. Not literally, of course, but it's something that they're doing
I don't know.
day by day. So it's almost second nature to them. And as well as that, you have the comfort of knowing that heat engineer and a plumber who has done this has been in your house. You have their number, and you can pick up the phone to them, to ourselves, or to Omni at any stage.
Very good. Jenna, any more questions there?
Yeah, another question is what benefits does one see in retrofit by switching from radiators to underfloor heating beyond aesthetics? And in other hand, efficiency within the room, quality, warming, temperature, maintenance.
Dan, you want to take that?
So that was what are the benefits of going for underfloor in a retrofit over and above the aesthetic?
Over for versus radiators.
Okay. So retrofit, you've got the potential efficiency increases. Now, assuming your heat losses are not horrendous, literally taking a radiator out and replacing it with underfloor heating, you will see an improvement in efficiency. The beauty with underfloor heating is that we're designing a system that's going to be running at probably a maximum of somewhere around sort of 50 degrees. So if you've got an existing condensing boiler, just by taking the radiators out, which would probably be running at maybe 60, 70 degrees, putting in an underfloor heating system that's running at 50 degrees, the temperature of the water coming back from the system tends to be low enough for that condensing boiler to actually start to condense during heating operations. So usually what happens with a radiator system, to keep the sizes down, they're designed with quite high flow temperatures. The problem with that is the flow temperatures are too high. More specific, the return temperatures are too high for the system to actually perform as a condensing boiler. So by dropping my flow temperature, I'm limiting my flow temperature because of the underfloor. My return temperature by its nature is lower. It means that the water going back to the boiler is low enough for the boiler to condense. So where you've got a boiler with a quoted efficiency of 92%, you're more likely to see that, as opposed to a boiler fitted with a radiator system where our return temperatures are above that condensing point. I may not be getting anything more than sort of 85% efficiency out of the boiler. So just by swapping between the two, because of the lower temperatures, I get a much better efficiency out of my heating appliance.
Is there a percentage on that, Dan, over a year, or can you hang a number on it?
It's difficult because you could probably see a 15 to 20% increase in efficiency just by getting the boiler to condense more.
Okay. But then obviously there's an energy saving on that in running costs.
Well, absolutely. Your primary heat source is more efficient. It consumes less energy to produce the same amount of power, or same amount of heat. So you may be paying, or you'll be paying less to have a system that's more comfortable than what you had with the radiator system. And the other thing with radiators is you tend to get a lot more convected heat. So the room, you get this movement of warm air around the room. Where you've got that movement of air around the room, that can actually drive heat losses slightly higher as well. It's difficult to put a figure to it, but because we're going to the underfloor heating, we're not reliant on that convected current. The actual heat loss from the room will slightly reduce because we're not driving warm air currents around the room quite so much.
Yeah, I actually read something on that myself. I mean, if you're asthmatic or anything like that, I read that underfloor was better in situations like that because it's a more stable environment.
It is. Underfloor is a radiant heating system, so it relies on infrared radiation as opposed to the movement of warm air. So radiators are called radiators, but they really should be called convectors. So they're reliant on the air kind of sat around the radiator being warmed by the radiator, which then makes the warm air is more buoyant, so it actually floats. And as it floats, you've kind of got this movement of that warm, buoyant air around the room. And of course, any dust, skin, dead skin, whatever it might be, gets dragged around the room by that movement of air. So when you first switch the heating system, like when you first switch the radiators on at the beginning of the heating system, you always get that. It's hard to describe. It's almost like a slightly weird smell to the air. But that's all the airborne dust and everything else. But you're breathing that in. And if you've got respiratory issues, that can really aggravate them. Whereas with an underfloor heating system, we're reliant on infrared radiation. So we're not pushing the air around. So you don't get that kind of aggravation of respiratory problems so much. Well, actually, you don't get it at all with it.
Jen, anything else?
Well, I'll read out the next question there, Ian, if everyone can hear me.
Yeah, loud and clear.
Yeah. So I want to ask, is there a minimum setting on a Bosch 30 kilowatt propane condensing boiler where I'll be losing efficiency benefits by running it at 40 degrees flow temperature? And that's probably one more that Bosch would be able to answer, but I'd say like on most boilers, you can't set min and max temperatures based on what kind of heating system you're trying to satisfy. But I mean, I don't know if you have anything to add to that, Dan.
I would probably take a step back as well. So if it's a combi, I don't know if it's a combi or if it's a system boiler. I'm assuming it's going to be a combi potentially. The reason why it's 30 kilowatts is probably more to do with your hot water demand than it is your space heating demand. So it's then understanding the minimum capacity of that boiler. So boilers modulate. They've got an upper limit and a lower limit. So 30 kilowatts would be its upper capacity. It will modulate down to maybe, I don't know, 15 kilowatts, whatever it might be. But it's understanding where your heat load fits in relation to that minimum turn down, and then potentially trying to derate the boiler to a certain extent to get your heat load and the modulation of the boiler to match a little bit more. Some of the inefficiencies can creep in where you've got a big combi specifically and quite a low heating load. And once the boiler starts, or the house starts to come up to temperature, the boiler cycles. So what you might notice is when it's slightly milder outside and the rooms are all coming up to temperature, you'll hear the boiler kicking in and out. And it's that boiler cycling that actually starts to decrease the efficiency quite considerably. Flow temperature is a good way of maximizing the efficiency, but it will be a combination of kind of load matching and driving that flow temperature to a point where it maximizes condensing for that boiler. But you best speak to Bosch because they'll be able to give you proper specifics rather than just kind of the generalization.
Thanks, Dan. I'm glad I asked you that question and you were here, that's for sure.
Another question here, Dan, would be floor types. Someone's saying, I notice engineered wood, laminate, but not solid wood. Any comment on that?
We tend to say engineered wood because we get more questions about engineered wood. You can use engineered woods, you can use solid woods. The really most important thing with any wooden product is to remember it's a natural material, so it sits in equilibrium with the environment. So if you're in a highly humid environment, the wood will contain a lot more moisture, which means it's got more volume. But once you put it onto the floor and it starts to dry out, it's going to lose volume. It will dry, the moisture's evaporated, and the wood will shrink. So the key thing is making sure that whether it's solid woods or engineered woods, your floor covering is properly acclimatized. And that might take a couple of days, it might take a couple of weeks. But given the kind of the cost of a wooden floor, spending a few extra weeks just making sure it's properly acclimatized is certainly, from my perspective, it's worth doing. But that's the key thing with it. It's just making sure it's acclimatized properly to the environment that you're installing it in. And performance-wise, they perform from a thermal conductivity perspective, they're both very, very similar in that respect.
I think, Dan, we were looking at a show of the weekend, and we had a question in terms of solid flooring and would it be sustainable using an underfloor heating, like the floor temperature. And I think this is something to just to let everyone know that I think the floor temperature will correlate with the temperature of the palm of your hand. So with a lot of flooring contractors or a lot of flooring suppliers, they will recommend, as you said, that if you're using concrete or timber flooring, that it is allowed into a house for a period of time. It could be you take into consideration the drying time of a screed, as we talked earlier on, and also the climatization of timber flooring within a house. There are certain types of timber flooring that the manufacturer that would recommend that it could sit within your house for up to 6 weeks. So once it's acclimatized to the temperature of your house, once the house is sealed and the heating is put on, I don't think there's ever going to be an issue with that.
But that's it. The main thing is to acclimatize it, and it's not something that you can rush.
Very good.
The next question will be mostly for Mick, for Rain, of course. Is using XPS 200 on a concrete floor in an apartment retrofit for heating and hot water from an A2W system. What info would you require for a quote?
In terms of for a quote, well, to answer the question first, yes, your XPS system can be used if it's a new apartment and you're going directly onto a precast or a hollow core floor. you might need to use a self-leveling compound just to make sure that your substrate is level. But in order to provide you a quote, as I said, we carry most of the stock here in our storehouse in Knockmitten Lane in Dublin. If you have a floor plan of the area that you're looking to put the underfloor heating into, you can send that over to us at any of our channels by mail, or if you reach out to Jen, it will get to myself and Ryan here, who will be able to look at the square meterage that is required, look at the amount of loops that is required, which will tie into the size of your manifold and everything like that. So very little information is required in order to provide you a quote. But if you can send over a floor plan, we'd be more than delighted to pull together a competitive quote for you and get it back out to you.
Okay, that seems to be it. Very good.
No, we still have a few more, sorry.
Okay, sorry. Yes, we wanted to go to the lunch.
Yeah, so Gordon asks, for large cathedral ceiling rooms, does underfloor heating make sense or not? Probably touching on the radiation versus convection heating mechanism, but you tell me. So I guess, yeah, rooms with particularly high ceilings, would that be a good environment to have underfloor heating in?
Yeah, absolutely. So with underfloor heating is more of a radiant heat than the convected heat. What you tend to find is you get a column of air above the floor to about 2 meters is heated kind of directly by the underfloor itself. So you tend to get the heat, it will stratify between the floor level and around 2 meters. So the fact that it's a much higher ceiling doesn't really come into too much effect. We do need to be careful of air changes and potential movement of air above the kind of the occupied zone for all intents and purposes, but it's something that's done quite frequently is the much higher ceiling heights. Yeah, design practices will actually give you a factor to increase your heat load by for ceiling heights above the standard kind of 8 foot or 2.4 meters, whatever it might be. So absolutely. Well, probably the best way of putting it is from a design perspective, but from experience, it isn't usually a problem. It's very rarely a problem in effect. The issue with radiators in that particular application is your heat will stratify at ceiling level. So that's the point at which you start to look at having to employ anti-stratification fans. So you have a big slow moving fan that sits on the ceiling that then just tries to push that warm air back into the occupied zone. But you don't need that with underfloor heating.
Yeah, and I actually, I spoke to Gordon for a while yesterday, and so I'm kind of familiar with his project. He brought up the ceiling fan, so I'm sure he'll be happy that you that you addressed that as well, Dan, because that was something that came up in conversation yesterday. The next question from Martin, and Mick, you might chime in with this one again. Just looking for the difference on cost between ours and other systems. So you might like to comment there.
Yeah, in terms of cost, it does come back to how relative what you're comparing against. So when we're looking at some of the encapsulated systems, they're not really there's not really an alternative. There are companies who do screeded systems on upper ground floors and first floors, but the cost of those is phenomenal. So when we're talking about the encapsulated systems and we're looking at say ground floor and first floor, the cost can only be kind of worked out looking at your square meterage. But in relative terms, when you take a ground floor, and this is something that pops into our inbox on a daily basis at this stage, where we're looking at retrofitting an XPS system to the ground. Your rough cost, and again, this ties into how many loops, your ground floor area, your size of your manifold, everything like that. But on average, you could be talking somewhere 55 to 60 euro per square meter. Now, in relation to putting some thermal mass system in there on these older retrofit houses, the only way of putting that in is that if you excavate down to roughly about 400 mil and build it back up to comply with Part L of the building regulations. And what's happening there is, to give a full overview of it, is that this is a structural job which can only be carried out by a builder. So you will excavate your whole ground floor. Again, the costs vary different, the difference on the size of the footprint of the ground floor, but you could look at anywhere from a cost of 20 to 25 to 30,000 euro for a builder to come in to dig out to allow you to put underfloor heating on the ground floor. So using something like an XPS system where it's retrofitted on top of an existing floor, your cost could be somewhere in the region of 5,000 euro, where you have a full working underfloor heating system within your house. So the cost against, you have to look at what you're costing against, and what systems are available for the build up within the house. Again, Dan, I'll just see what your thoughts on that are.
Exactly the same, Michael. I suppose the thing to add really is well, I'll take a step back. One of the questions we get asked quite a lot about overlay systems, where you've got an existing slab, so you've got a load bearing slab sat directly on the ground. Is it worth lifting the floor up to put insulation in? And it's then looking at a case of, okay, we can calculate your downward losses for a floor with no insulation in. That's a relatively easy thing to do. Similarly, we can do the same calculation with an underfloor heating overlay system laid across the top of an existing ground bearing slab with no insulation, and so we can calculate the losses downwards from that, and we can calculate losses downwards with 150 mil insulation, whatever it might be, and then we can compare and contrast the energy costs associated with those downward losses. Plus, then you've got the cost that you were talking about lifting gunning the floors out, 400 mil down, 200 mil of Kingspan or Celotex, whatever it might be, underfloor in, Kingspan, Celotex. No, we've already done that, haven't we? Screed over the top of that, and then working out how much that's likely to cost. Now, we've done those calculations, and the payback time of a complete removal of the floor, re-insulation and relaying of the slab versus the energy costs of the downward losses with an overlay system, the payback period is about 150 to 200 years. So from an economic perspective, from an energy flow perspective, it doesn't really make a great deal of sense to go down the route of ripping everything out to put insulation in, put slabs down, and kind of redo the underfloor, as you were saying. So from an environmental perspective and from an energy perspective, as long as you're not sat right on the water table, there isn't really any reason to lift the slab.
Excellent. Yeah, thanks, Dan. And we've one more question for. Oh no, sorry. Two more from Gordon. Fair play, Gordon. You're really getting your mileage out of the session today, making us work for it. So Gordon asks, in retrofits, it's sounding like it's difficult to mix and match underfloor and conventional radiators. He says, I assume he says in different rooms. So like I suppose having underfloor heating in one room and radiators in another. And ask if we could discuss that. I wouldn't like, if I could chime in, I would say I wouldn't really say it is quite difficult. You can treat the manifold that's feeding the underfloor system as almost just a radiator on its own, and still have your flow from the boilers feeding into the radiator system separately, if that's what you wish. I mean, I don't know if if it is just as simple as that, Dan. If you have anything to add.
It absolutely it is. If you look at way heating systems are designed, they're zoned. So you might have, so you've got a standalone boiler. You'll have a standalone boiler, hot water cylinder, and your heating system. So that's already two zones in effect. All we're doing with the underfloor is taking the heating side of it and splitting that zone down again. So I've got one control that looks after my radiators, and then I've got another control that then looks after my underfloor heating. So I need that segregation of control because the underfloor works at a slightly different rate to radiators. But from a plumbing perspective and from a controls perspective, it's something that's done really commonly, really frequently, and it isn't a difficult thing to achieve. Certainly on a room by room basis, or more frequently that we get over here, is your downstairs might be one thing, and then your upstairs might be a slightly different kind of system. But it's all achievable. I think the only thing that I will say is where you've got the mismatches in height. That's probably where the complexities are going to start to come in. So if you put underfloor in one room, if it's an overlay system, you've got the depth of the overlay at the threshold of the door to then to contend with. If you're doing it in a suspended floor, where you can actually sink the underfloor heating to sit within the kind of the interjoist space, you've got no variations in height. So the logistics of the height differences will very much be dependent on the floor, the actual structure of the floor itself, and what solution we go for in that particular aspect. So it's all achievable.
Thanks, Dan. Ryan, does Gordon have another question?
There is one more from Gordon, but I'm actually just typing up an answer through text as I was doing that while Dan was answering the last question. There is one more from someone else. They've said, my project is probably a good example of the question on floor insulation losses. About 50% of my 75 square meter area is battened 50 mil space under the timber floor. 50% of it is screeded sand cement. So I'm opting to take up the sand and cement screed in my kitchen/utility to fit a 50 mil XPS system. Interesting that you've done the calcs to show that removing the subfloor to reinstall 150 insulation has 150-year pay.
Yeah, it's a long time.
It's yeah. That was from Anonymous. Yeah.
With that particular application, I'd be more worried about the suspended floor than I would the solid floor. The thing with suspended floors, certainly on the ground floor, is they tend to be ventilated. So if you're walking around the house, if you're walking around the outside of the house, you might find little air bricks. If you've got air bricks, it means that underfloor void is ventilated. So there's movement of air in and around the underfloor structure. And that was always done to stop moisture being a problem under the floor itself. So it keeps the timbers dry, basically. But the issue with that is I've got cold air moving under my underfloor heating, plus I've got the room above where I want the heat to go. So if I've got no way of mitigating the losses into that ventilated void, that's more of a problem. I mean, my losses downwards at that particular application could be 40 or 45, maybe even 50% of the power going into the floor is going to heat the void, which is then going out and heating the environment, which is obviously what we don't want to happen with the underfloor heating system. So I'd be more inclined to be looking at ways of insulating the suspended floor, and be less concerned about the solid ground floor.
Yeah. Very good, gentlemen. Thanks very much. It's been most interesting. I'd like to thank Dan, Mick, Ryan, and my colleague to my right, Jen, who's doing all the work in the background that no one sees. We're like a swan. We're calm above and running like mad underneath. I'd like to thank everybody that signed up for the session. I really hope you found it informative and insightful. I think you can see that this new alternative system is efficient, retrofit friendly, so no need for digging up existing floors, no need for screeds, so making the installation quick and easier. Suitable for upper floors, which was something that I definitely wanted to get a message across, because people just simply don't know it's possible. Faster heat response time when compared to concrete slab. Begs the question, why are we heating a concrete slab? So if you've got more questions or want to discuss a project, come back us at any time. Phone us on Dublin 1409 8000. Stay connected. Follow us on LinkedIn, Instagram, and TikTok for industry updates, project insights. You'll see the how to do's with Mick. I'm calling him Mattress Mick now, so we can call him Underfloor Mick. And we'd like to thank you for your time again, and we look forward to working with you in the future.
Thank you.
Thank you.
Thank you, everyone.